So as continuation, we are learning about virtual function, and in virtual function, the basic scenario is regarding runtime polymorphism. Now, we have learned about polymorphism earlier. Now, specifically, what will be runtime polymorphism? So, we have already discussed a topic where you have compile time and runtime errors. And compile time happened while the program was being compiled, and any errors that is respective to syntax or maybe missing variables could have been pointed out at that time. So that is basically your compile time error. Now, any mismatch that happens during the runtime of the program would result in a runtime error. So similarly, we have polymorphism again. Again, polymorphism can be classified into runtime also. And in runtime polymorphism, what happens is there is more than one version of the same entity which can run at the same time. So basically, if you want to look at this program, you can see that this class A has got a function display, and again this class B has got a function display. Now, at the time of, we have already looked into this in the previous topic, where an object is created. We have a pointer over here which belongs to class A, which is a base class, and we have an object that is created of the derived class B. Now, if you look over here, there could be a confusion where, whether the display of the base class or the derived class should run. So, as seen earlier in this particular circumstance, we have seen that by this particular situation, when this object or pointer A is calling display function, it usually runs a function of A. So we'll try running this program. So I'm going to copy this from here, and we have this set of code here, which I will be copying it to this one, or compiler, and pasting it over here. So if you look over here, you have this class A which has variable x equal to 5. We are supposed to display the value of x using this function. Again, the derived class B is there, which is supposed to display the value of y by this particular function display. Again, if you look over here, display over here is existing as well as display is also existing in the derived class. This could result in a runtime polymorphism where exactly how it happens will be explained right now. So we have a pointer declared here which belongs to the base class or class A. We have the object which is of the derived class. Now you have a statement over here which connects the pointer and the object. Okay, fine, it should be clear. Now this pointer is calling the display function. Now this pointer corresponds to what? It belongs to object of the derived class. So what would be typically expected? You should run the display of the derived class, which means you should display value of y is the value of y should be displayed. Now when we run this program, actually we get to see that it has displayed value of x is 5, which means even though we expected the function of the derived class to run, it actually ran the function of the base class. Now this is in contradiction to what we expected. This can be solved. Now what we are discussing basically here is we are having this predicament called runtime polymorphism. We expect the thing to run from the derived class, but it actually runs a thing of the base class. So this can be solved with the help of a virtual function concept. Now what is a virtual function? A C++ virtual function is a member function in the base class that you redefine in the derived class. It is actually a member function in the base class which can be redefined in the derived class, and it is declared using the virtual keyword. It is used to tell the compiler to perform dynamic linkage or late binding on the function, which basically conveys the fact that if it is called by the object of the derived class, it should run the function of the derived class. Now we'll run the same program over here, I'm making this function virtual over here, void virtual display. Now this function is made virtual. I'm running this, and you can see the output has become value of y is 10, which means it has run the function of the derived class. Now this is basically the role of the virtual function in supporting runtime polymorphism. We have already seen that the function without the virtual keyword, this program without the virtual keyword, it will be running the function of the base class, and with the virtual keyword it is taking care of the runtime polymorphism, understanding that the object belongs to the derived class, and it will be displaying the function of the derived class. The problem will not be the same if the object belongs to the base class itself. So here, if you look over here, the pointer is also of the A class, which is a base class, and the object is also of the base class. When we run this program, there is no need for your runtime polymorphism here, because it is straight away calling the function of the base class. So there is no issue over here. The issue comes only when, or even if this is the base class pointer and if this is the base class object, it should be clear that if this particular thing is calling the function display, it will automatically run this function of this derived class. So we'll run this particular program, and again you can see that it will be running the output. You'll be getting the output as value of y is 10. So three situations are there over here. You have the base class pointer and the base class object, whereby it will run the, whereas there is no confusion or need of a virtual keyword. The derived class pointer and the derived class object also doesn't need the virtual keyword out over there. But if the pointer belongs to the base class and the object belongs to the base derived class, you need the virtual keyword to actually run the desired function. Now I hope this creates, or this clears the topic of what is a virtual function, and I have this programs over here which is which gives you the idea, and it supports the fact that it encourages or supports runtime polymorphism, dynamic linkage, or late bindage, referring to the fact that the function call is resolved during the runtime. The next concept is regarding virtual constructors and destructors. Like we have already learned about functions declared as virtual, and virtual as a keyword we know now it supports runtime polymorphism. So again, with respect to constructors and destructors, the virtual keyword added should support the runtime polymorphism in terms of constructors and destructors, but there are certain aspects over here. So when we talk about constructors primarily, we know that the virtual keyword is associated with polymorphic behavior. As mentioned in the previous description, your virtual supports runtime polymorphism. That is what is mentioned here. But here, when it comes to constructor, there cannot be anything polymorphic, because the object exists only when a constructor ends. Like we know, what is a constructor basically used for? For creation of an object or for initialization of an object, we are using a constructor. Now, once an object is to be created, there is no polymorphism involved. I hope that concept is clear. There is no confusion regarding to how this polymorphism should run or which function is to be run. If an object has to be created, naturally a constructor will have to run, and hence there won't be anything polymorphic about the behavior of the constructor, and an object, it will exist only after the constructor function ends. So hence an object can have only one constructor, and hence not multiple constructors are permitted, and hence the concept of a virtual constructor is not possible. I hope that idea is clear. Now when we talk about virtual destructors, we have usually used constructors to initialize an object, and we have seen destructors being used to destroy an object being created. Now, with advancement in programming, there are two types of um, basic destruction of an object happening. So one can be with and another can be without the use of a keyword called new. So without the new keyword, an object creation happens in this manner. An object with automatic storage duration, which means it will be destructed automatically upon exit from the scope in which it is defined. This is something that we have looked into earlier in earlier sessions. If you remember the first module taken, we had explained that a destructor will function when it exits from a loop, from a branch, or from the main program. So that is a case mentioned over here. Now, if you're using or creating an object with the new keyword, if that is a case, then what would happen is an object will not be destroyed until you explicitly use a delete keyword to do so. So in this case, we have to use the keyword delete also to destroy the object. And here you can see that when the base class pointer is destructed using the delete operator, the destructor of the base class as well as the derived class is executed. Now, with the destruction of this, now we look into this program. So we have the object pointer that belongs to the base class, and you have the object that belongs to the derived class. I would request you to run this program by trying out this combination of the as we have done previously, that is a pointer belonging to base class or derived class and the object belonging to the base class or the derived class. Please try running this same program in the 4 different versions that we had tried out earlier and see and understand its effect. Now, I'll be explaining the concept of a virtual destructor and its impact on this particular program, where we have a pointer that is designated of the base class and the object that is created of the derived class. So if you don't know, look over here, you have the virtual keyword associated with the destructor and the base class, and your derived class also has a destructor. So when we run this particular program, you can see that it has run properly, and you have initiated an object, so it goes to the base class constructor runs, then the derived class constructor runs, then the destructor derived runs, and then the base class destructor also runs. That is with the keyword virtual. I'm removing this keyword virtual over there, so that means it would be a normal B over there and destructor over there. So when we run this program, we can see that your output is missing the destructor of the derived class. This because of the fact that the object is of the derived class, and hence the derived class destructor only works. If the keyword virtual was instructed over here, it would have automatically run the base class destructor also. So my request to you would be to copy this program and to see the versions or outcomes of varying this pointer from the base class to the derived class and creating objects over here which belongs to the base class and derived class, and to study its impact and the after effects in the running of a virtual destructor. So that would be the end of this topic.